Okay, so today I'm going to teach you how to solve for x where you have the fractions, where one of the terms it could be a fraction. Maybe let's consider this to be example number 1, where you are given, let's say, 1 over 2x that is being added to 7, and this being equals to let's say 4. So just like we did with simple linear equations where there were no fractions involved, we knew that in the end we have to have numbers on one side and letters on one side. We still follow the same principle even when we are dealing with this type of an equation where one or more of the given terms may be a fraction. So obviously it's half a letter, so we just leave it on the left hand side because that half is attached to a letter. On the right hand side you have a 4, you take 7 to the other side, it changes its sign, it becomes minus 7. You still have your half on the left hand side, you just need to work out this on the right hand side. Definitely 4 minus 7 will give you negative 3. This is where you need to be careful. So you've got many ways in which you can work it out. Remember, it is the half which is attached to the x, so that means you need to detach this half. So one of the options is for you to divide on both sides by half. The reason why you would divide on both sides by exactly that half is so that it cancels completely. So that means that half cancels completely with that. Then you remain with x being equals 2. Then you have that negative 3 over a half, which might end up as negative 6. But you can punch it on your calculator, or you can just work it out where you say negative 3 divided by a half, and then you multiply where you swap the 1 and the 2, and it ends up giving you that final answer of negative 6. So what I mean is, if you have that negative 3 which is dividing that half, mathematically we know that it should be the same as negative 3 where you multiply. So you change that division sign. That means as you change it, the 2 goes to the top, and then you say over 1. So now it clearly looks like you are going to have a negative 6 because you end up having that negative 3 multiplying that 2, which ends up being negative 6, and that should be the end of it. So as we continue, you will therefore notice how to deal with such where you get to almost the final answer. So now let's say you have negative 3 minus 2x over 3, and this being equated to, let's say, negative 4. Again, in this case, you will definitely leave the negative 2x over 3 on the left hand side equals to negative 4. That 3 will come to this right hand side, it changes the sign, it becomes positive 3. You still have your negative 2x over 3 being equals to that plus that, it will definitely be negative 1. Remember, it's always best to punch it on a calculator in case if you are not sure. So something very much important, remember that when you have negative 2x over 3, it is still the same as negative 2 over 3, and this x being there, which is still equals to that same thing. So the reason why I'm doing it this way, it's so that I will say let's divide by exactly that negative 2 over 3. I'm sure by now you know why. Obviously, what you do on the left, you do on the right. So the reason why you divide by that is so that the whole of this can cancel completely with that. Then you remain with your x, which will be equals to, can punch that on your calculator. It should give you positive 3/2. Let's see, when we punch it on a calculator, it's -1 divided by, in brackets, it is that -2/3. Yes, it gives positive 3/2, and that should be the end of it. Maybe let's look at another example and see how far we can go. Let's say, as example number 3, we have 3x divided by 4, where we minus 5, and this is equated to 1. Again, you want to have your letters on the left, numbers on the right. So it is for this reason why I will still write that 3x/4 on this side, and then already on the right hand side I have 1. I will take this to the other side, it will change the sign, it becomes +5. And then what you do is just to remember that this is still the same as that, and then this plus that, definitely that is 6. So what you do, you detach that fraction of that. Remember, whatever that you do on the left, you also do on the right. So that means the whole of this will cancel with that. Then you've got your x being equals to, how you punch this on your calculator, you can just say 6 divided by, in brackets, 3/4, and it will definitely give you an answer of which it is 8. So that's how you would work it out. Maybe without wasting much of our precious time, let's move on to another example. In this case, I'm having it as example number 4. So example number 4, let's say you have 6, which is equals to, in this case, we can still say that. And then maybe let's add it with 2. Okay, then it's fine. This is what you are given. Remember, letters one side, numbers one side. So you can still take these 2 to the left hand side, so it doesn't really matter that much. You can say 6 minus 2, and this is equals to. Most importantly, you have an invisible one there. It may look like it is just x/5, but please be aware that it is actually the same as 1/5 multiplying that x over there. So that means when it's written like this, that x, it always multiplies the numerator, or in short, the letter always multiplies the numerator being the number above the over, and then the one below being the denominator. So it's like, now I've rewritten it in this way, so that I will say 6 minus 2, definitely that is 4, being equals 2. Then I know that I'm going to easily detach that 1/5 by simply dividing by. You can see I'm putting it inside the brackets just to eliminate chances of making any mistakes when I have to either punch it on a calculator or work it out with the other one on the other side. So you can see that's how you detach a number, which could be a fraction or whatever the case may be, to a letter. So you end up having that letter x being equals to, punch it on a calculator, 4 divided by, inside the brackets, 1/4 equals 2, and then we are having 20 there. So if you remember, I said it's best to write it as letter equals a number. Something that you might need to easily remember, it's like you're saying Desmond is my name. When it is written in this format of 20 is equals to x, but rather write it this way and say actually x is equals to 20. So in this way, it's like you say my name is Desmond. So I hope you fully understand it. So now Let's continue with another example, maybe this being example number 5, where you may be given 2 minus x and the whole of that being divided by 3, and that being equated to 4. So in this case, you can see that you just have one term on the left hand side and you also have one term on the right hand side. You can do it in many ways, but maybe let me just show you, and not necessarily an easy way to go about it, because there are other ways which maybe seem to be easy. But how you work it out, you just cross multiply, force this one on the right hand side to be a fraction. You see there you have that over that. On this side, to force it to be a fraction, you divide it by 1, just so that you can cross. When we say cross, it means this cross to multiply that, and this at the bottom cross to multiply that. So it's like that one will be multiplying that 2 minus x equals to that 3 will be multiplying that 4. It doesn't matter if you say 4 times 3 or 3 times 4. Then this is where you now do this by that by that, just so that you remove the brackets. Definitely you will have 2 minusing 1x there. That times that, it will definitely be 12. Then now you can take this 2 to the other side. You remain with negative x, which will be equals to, obviously 12, that 2 changes the sign, it becomes minus 2. Then please remember that you have invisible 1 there. So let's just write it as invisible 1x being equals to that minus that. It will definitely be 10. Now you need to detach that negative 1. Can you see? You detach it, it removes completely. Then your x will be equals to 10 divided by negative 1. It will be negative 10. Looks to be a longer method, but trust me when I say, if you do it this way and get used to doing it this way, trust me, any type of a math problem that looks like this, you will easily work it out, and you will even be able to understand some more complicated problems. So let me just continue to do some more and see what would be expected of you to do in case if you are given something a bit different. So let's see. Let's say this would be example number 6. Let's say you are given x, maybe this is being divided by 6, where we minus 5 over 2, and this being equated to negative 1. Remember, the fraction that has a letter, I would rather leave it on the left hand side, and then already I'm having negative 1, which I will plus it by 5 over 2. So the 5 over 2, I'm taking it to the other side. Remember, you have invisible 1 there. That is why it would be best for me to write it as that, just so that it therefore becomes easier for me to detach it. But negative 1, when you plus it with 5 over 2, it gives you that 3 over 4. So that means you have positive 3 over 2, not over 4, but over 2. So it is now up to you in terms of how you work it out. One can still say, now I'm going to detach that 1 over 6. So remember, whatever that you do on the left, you also do on the right, or vice versa. So that's how you detach that 1 over 6. And then you end up having your x being equals 2. You can punch that on your calculator and say 3 over 2 divided by, in the brackets, you will therefore say 1 over 6 equals 2. It therefore gives you 9. And that should be the end of it. I hope that makes sense. Remember, this is not the only way to work it out, but as I've indicated previously, I'm training you on finding the correct final answer. You might find that your teacher wants you to use a different method. It looks like I'm running out of blank pages there. Maybe let me try to erase clear. And then now that I've erased, let me just add some more pages just in case. I'm going to be having some more examples. Okay, so now let me just make sure that I'm writing on the page. Okay, so now let's say this to be example number 7, where let's say you have negative 3 over 4x. Maybe let's add it to 2. Then let's say this is equals to 1 over 2. Yes, let's say it is equals to 1 over 2. Again, this negative 3 over 4x, I will just leave it on the left hand side. And then I will therefore say this 1 over 2, I will take that 2 to the other side. Definitely, it will have to change its sign. And then you now have your negative 3 over 4x, which will be equals to half minus 2. Definitely that should be what is it, negative 1.5, which is negative 3 over 2. Let's see, negative a half, not negative a half, but half minus 2, yes, negative 3 over 2. So I think by now you do know very well that I'm going to divide both sides by that, just so that I can detach it. Then this should be equals to, on this side I'm having that negative 3 over 2, where I need to divide it by that, just so that this will cancel completely with that. And then I'm just trying to figure out how I've written this. It looks like there is something that I've done which I was not supposed to do. Okay, let me rewrite this in a way that will not leave you with some questions or uncertainties. I will actually want to start it from this step, yes, where the next thing to do is for you to detach that. So you will divide by exactly this same thing, just so that it will cancel. Whatever that you do on the left, you also do on the right. I think this is a proper way of writing it. Negative that over that, just so that this will cancel completely with that, and then you have your x, which will be equals to, you can now try to punch that on your calculator, where you say negative 3 over 2 divided by, in the brackets you have your negative 3 over 4, and that it is equals to 2. So that's how you would work it out. Maybe let's squeeze in the last example, and then from there we will see if we can find something a bit more challenging. So let's say here we have now 5 minus let's say x, that is being added to 1, and then that being over 3, and this is equals to 2. So it shouldn't be complicated, because I will just take that 5 to the other side. So that means here I'll just remain with that, which should be equals to, then 2 minus 5. Then I'm definitely having my negative x plus 1 over 3, which is going to be equals to, definitely this will be negative 3. Already you have negative on the left and on the right. They can just straight away cancel. Then if you remember, I said you can therefore force this one to be a fraction, because you now have x plus 1 over 3, and then on the right hand side that and that, which is where you now cross multiply. And you know, when you multiply by 1, it remains as it is. It doesn't change. 3 times 3, definitely that is 9. then you end up having your x being equals to 10. That should be the end of it. Nope, not 10. Why am I saying it's 10? It should be 8. You see the problem with not doing a full step, you end up making mistakes. You need to take this to the other side. It will become 9 minus 1, where x it is equals to 9 minus 1, that is 8. So that should be the end of it. I think I've covered all that I wanted to cover, and I don't think there's anything that I've missed out. It looks like I've covered all that I wanted to cover for now. Okay, then it's fine. This one I will just